Hello guys and welcome. In this video I'd like us to talk about multiplication of matrices. So let's dive into it without wasting any time. So let's suppose you have matrix A, sorry about that. Suppose you have matrix A with the entries uh, 1, -1 and 2, and you have matrix B with the entries uh, -1, 2 and 4, like that. Okay, so the first thing that we have to consider is the order of matrix A and the order of matrix B before we can do anything further. So let's look at that. We see that on matrix A we have one row and one, two, three columns. From the previous videos we talked about rows and columns, that number of rows times the number of columns, it gives us the order of the matrix. So in this case, since we have one row and three columns in total, that means the order of matrix A is basically the order of matrix A is basically 1 by 3. Okay, so what about the order of matrix B? We see that we have one column going vertical like that, and going horizontal we have 1, 2, and 3. So basically for B we have 3 by 1. The order of matrix B is 3 by 1. So if we want to compute the product of matrix A multiplied by matrix B, we have to first consider the order of matrix A and compare it to the order of matrix B. What are we going to basically consider? We are going to consider the following. Let me just rewrite the orders down here so you guys can see what I'm talking about. So we know the order of A, since it is starting first, we're going to write it first 1 by 3. And the order of matrix B is 3 by 1. Okay, 3 by 1, like that. So remember, this number is called rows, and this one represents columns in A. This one represents rows in B, and this one represents columns. Okay, so the number of columns in A should be the same as the number of rows in B. So we see that these numbers are the same. They are both equal to 3. Okay, so in that case, then we know that the product of matrix A and B is defined. We can find that product. Okay, so what about these numbers that remain there, 1 and 1? They basically give us the order of matrix A, B. So that order is going to be 1 by 1. So before we even compute the matrix, we already know that the order of matrix AB is going to be 1 by 1. Okay, so we can quickly um, compute that product and see what is going to happen, or how are we going to attain that. So what is happening is that when we are coming on matrix A here, let me just quickly erase these numbers here so they do not disturb us. So what we are going to do is that we are going to multiply the corresponding row in A with the corresponding column in B. Okay, so in this case, the corresponding column that I'm talking about is basically these numbers here going down. So each entry, in this case 1, is going to be multiplied with -1, and then plus -1 multiplied by 2, and then plus 2 multiplied by 4. Okay, so all those sums of the product, they are going to give us only one entry in the matrix. Okay, so I'm going to quickly write down on the side here what I'm talking about so you guys can follow. Okay, don't worry, if you feel like you're a bit lost, feel free to rewind the video so that you can catch up with us. Okay, so let's start doing the product. Here it goes. We say that we are going to take this first number here on the first entry of A, which is 1, and we're going to multiply it with the first entry in B, which is -1. Then plus this number here on the second entry of A, -1, then multiply it with the second number there, which is 2 on the column. Then this number 2 plus 2 multiplied by 4. 4 is the last one there. Okay, so that product gives us negative 1, then negative 1 by 2, negative 2, then 2 by 4, plus 8. So it's giving us plus 8. So minus 1 minus 2 is minus 3 plus 8. That is basically equal to 5. So the matrix that we get now is only having one entry, which is 5. Okay, so we see that if we are trying to find the number of columns in this matrix, it's basically one column because columns are identified going vertically like this. And then if we are trying to identify the number of rows horizontally, it's also one. So that is why we agreed that the order of matrix AB is going to be one by one. So already from taking these two numbers, we knew what was going to be our order. So if you compute a calculation and you find that the order of the matrix that you're finding is not the same order that you speculated before doing the product, then no hurry. You have done something wrong in between. Okay. So now let's move forward and do other more examples where we have a 3 by 3 matrix, 2 by 2, where things are starting to get a bit shaky. But don't worry, guys, I'll get you through it. So just bear with me on this one. So let's write example matrices. Let's say we have a matrix A with the following entries: 1, minus 2, 3, then minus 4, then I can say minus 1, and just put a 0 there. You can choose any numbers. Then B with the entries 4, 6, 2, minus 1, minus, let's actually make B a 3 by 3. So I'm just going to extend that. Minus 1, 0, 1, then 2. Okay, I already have a 2, so let's just put a negative there. And then make a 3. Then minus, minus 2. No, minus, can just say minus 3, it's fine. You can choose any numbers you like. Then C, let's make C a 2 by 2 matrix. 2 by 2 matrix with entries negative 2, 1, 0, negative 1, like that. Okay, so let's identify the order of our matrices. So we see here we have 1, 2 rows, and then we have 1, 2, 3 columns. So it's basically a 2. It's basically a 2 by 2 by 3 matrix. In this one, we have 1, 2, 3 rows and 1, 2, 3 columns. So it's basically a 3 by 3 matrix. So we see that B is actually a square matrix. And on C, we have 1, 2, and 1, 2. 2 rows, 2 columns. So it's a 2 by 2 matrix. And also C is a square matrix, okay? It's a 2 by 2 matrix like that. Okay, so now can we compute the following products? AB, AB, can we compute BA? Can we compute CB? Can we compute BC? Can we compute AC and CA? Yeah, those should be enough examples to clarify how we do products of matrices. So now let's start off with AB. Since A is the starting matrix there, what is going to happen is that we're going to write down the order of A first. Okay, so I'm just going to do it one more time so you guys can get the jinx of it. Then followed by the order of B, which is 3 by 3. Okay, then from there, what I know is that I want this number here, the columns of A, to be equal to the number of rows in B. Okay, so since these two numbers are the same, we know that the product AB is defined. Okay, and the two numbers that remain there, 2 and 3, they give us the order of matrix AB. So basically, we know that the order of matrix AB is going to be something like a 2, a 2 by 3. Okay, before you even compute the matrix, you already know the order. So if we go wrong while we are busy with the calculation, then we will see this order not appearing. Okay, and we'll be like, let's go back and recheck. So now I'm gonna quickly just write AB. You see that it has to have 2 rows and 3 columns. So I'm just gonna make lines there. So that is the first, the second row. Then it has to have 1, 2, and 3 columns like that. So I'm just drawing this matrix without the entries so you guys can get the idea of how a matrix is gonna look like. Then here I'm gonna fill all the entries in. Okay. So this is the first entry, second entry, third entry, fourth entry, fifth, and sixth entry. Okay. So on the first entry for this one, what we are going to do is still the same procedure that we did on the previous example. What we did, let me just put that number back there. We had a 3. We had a 3. Okay. What we did was that we said the row in A is going to multiply with the column in B. Okay. So all the corresponding entries in A are going to multiply with the corresponding entries in B. So this row is going to multiply with this column. That is to say 1 is going to multiply with 4, negative 2 with minus 1, then 3 with minus 2. And we're going to take their summation. Then that will be filled on this first entry there. Okay, I'll just quickly write then what I'm talking about on the side. So I said 1 multiplied by 4, then plus minus 2 multiplied by minus 1, then plus 3 multiplied by minus 2. Okay, so if you notice, I take the number in the row of A and I multiply it with the number in the column of B. So 1 multiplied by 4, then I take this second number in the row of A minus 2 and I multiply it with the second number in the column of B, just like that. Then I took 3 multiplied with the negative 2 in the column of B. That is how you compute product in matrices. Okay, so that is the sum of all this product is going to give us a number that is there on the first entry there, only there. Okay, so 1 by 4 is 4, then minus 2. Oh, I didn't write that down. It's 4, then minus 2 by 1, that is positive 2, positive 2, positive 2, and 3 by minus 2, that is minus 6. Okay, so basically we see that this summation is going to give us 0. So this is basically equal to 0. Okay, so that is the entry here. We have 0 there. Okay, then now we go again. The same row is going to multiply this second column. That is going to give us the second entry there. Okay, now we are going to say 1 multiplied by 6. 1 multiplied by 6 plus minus 2 multiplied by 0 plus 3 multiplied by 3, which is going to give us, so it's the same thing, 1 multiplied by 6, then minus 2 multiplied by this 0, and 3 multiplied by that 3. Okay, so if you keep track of these numbers here, they are the ones that comes from the row of A. 1, 1, minus 2, minus 2, 3, 3. So they won't change. What is going to basically change is the column, the numbers from the column of B. So from on the first column, we have these numbers, which is 4, minus 1, and minus 2. And on the second entry, we have 6, 0, and 3. Okay, so now the product is giving us 6 by 1 is 6, then minus 2 by 0, that's going to fall away, then 3 by 9, 3 by 3 is 9. So we basically have 6 plus 9, which simplifies to 50. Okay, so on this entry here, we're going to have 50 like that. Okay, so now let's move on and do the third entry. So it's going to be the same row multiplied by the last column. Okay, so the number 1, going to be multiplied with 2 plus minus 2 multiplied by 1. I'm pretty sure you all are now following how we do the product of matrices. It is pretty easy. It is not that difficult. You just need to pay attention and follow what is going on. So 1 by 2 is 2, and minus 2 by 1, that is minus 2. 3 by minus 3, that is minus 9. So that simplifies to just minus 9. So the entry there is basically minus 9. Okay. Now we are moving on to the second row of matrix AB. Then we also have to use the second row of matrix A. Okay, on the second row we see it's minus 4, minus 1, 0. So this whole row here is going to multiply each column in B, like how the first row was doing. Okay, so here's what I mean. We're going to have minus 4 multiplied by 4 plus minus 1 multiplied by minus 1. Oh, my negatives are not visible enough. Let me just do this. So we said minus 1 minus 1 multiplied by minus 1, then plus 0 multiplied by minus 2. That is going to simplify to minus 4 multiplied by 4. That is going to give us minus 16. Minus 16 plus 1. Minus 16 plus 1. Since minus 1 by minus 1 will give us 1, and this will just fall away. So basically there we have minus 50. We have minus 1, 5. So on this entry here, we're going to have minus 50. Minus 15 like that. Then go ahead and do the second column in B. So that is minus 4 multiplied by 6 plus minus 1 minus 1 multiplied by 0 plus 0 multiplied by 3. Okay, so this falls away and that. So what we are left off is minus 4 by 6. That is minus 24. Okay, so on this entry here, we are going to get minus 24. Okay, now let's do the last multiplication. So this row is finally going to multiply with this last column in B. So we are going to have minus 4 multiplied by 2 plus minus 1 multiplied by 1 plus 0 multiplied by minus 3 equals, so this is going to fall away, then minus 1 by 1, that is just going to give us minus 1, then minus 4 by 2, that is going to give us minus 8. So this simplifies to minus 9. So on the entry there, and that entry there, we're also going to find minus 9. Okay, so the product AB is yielding a new matrix with entries 0, 15, minus 9, minus 15, minus 24, minus 24, minus 24, and minus 9, like that. Okay, so now what we can do is to see if ever the matrix BA, this matrix BA, is it going to be the same as matrix AB? Okay, is it going to be the same as matrix AB? That is if the matrix is defined. Okay, so since it's BA, that implies um, we are starting with matrix B, and matrix B has the order 3 by 3, And matrix A, we see that it has the order 2 by 3. Okay, since the number of columns in B is not equal to the number of columns in A, we see that this one is undefined. Okay, so it is undefined. So we cannot compute that. But on matrices, what you have to notice is that if you are having a matrix A multiplied with B, doesn't mean that matrix AB is the same as matrix BA. So that is not true. So they are not equal. Okay, they are not equal. So now let's move on to check CB. Can we compute the product between matrix C and B? We start off with matrix C. Matrix C, we see that it is going to have 2 columns, and matrix B has 3 rows. So since the number of rows and columns are not the same, we cannot compute such a calculation. So also this one is undefined. You see? Now BC, it is also going to be undefined. Why? You can go check that. Since we see that the number of columns in B are 3 and the number of rows in C are 2. So that is going to be undefined. What about AC? AC, we see that we are starting with matrix A. It has three, three columns, and C has 2 rows. So that is also going to be undefined. Okay, it's undefined. What about CA? Though AC is undefined, but CA is a different story. We are starting with matrix C. It has 2 columns, and matrix A has 2 rows. So though AC is undefined, but we can find CA. Okay, so let's quickly try and do that. I can move that down. Just gonna need some space here. Okay, so we know that CA, we're starting with matrix C. Matrix C has the order 2, has the order of 2 by 2, and matrix A has the order of 2 by 3. So these two numbers are the same. That is why we are able to do the product. And the numbers that remain is 2 and 3. And that shows us that we're going to have a 2 by 3 matrix. Okay. So we can go ahead and compute such a calculation quickly without having to rewrite all of this. I best believe you all are following on how we do all this calculation we did over here. If you're not following, feel free to go back on the video and make sure that this time around you follow on what we are doing. Okay, so now I'm just going to quickly do the matrix CA. So the matrix CA, we know that it has to be a 2 by 3. So we have to have 2 rows and 3 columns. So these are 2 rows, and 1, 2, 3 columns. Okay, so in the first entry, we see that, oh, we are going to multiply this row, with the first column in A. So minus 2 times 1, that's minus 2, and 1 times minus 4, that is minus 4. So minus 2 minus 4, that is going to give us minus 6. Okay, so in the first entry there, we're going to have minus 6. Let me just erase that. So like that. Then here we're gonna have minus 6. Okay, so this again is going to multiply with this. So minus 2 times minus 2, that is going to give us 4. Then 1 by minus 1, that is minus 1. So 4 minus 1, that is 3. What remains is 3. And minus 2 times 3, that is minus 6. So you're just going to have minus 6 there. Since 1 by 0, it's just going to be 0. So here we're going to have an entry of minus 6. Minus 6, like that. Okay, gonna have an entry of minus 6. Then on this entry here, this one, what are we going to have? We are changing the row. Since you're on the second row also here, we change the row. So it's 0 by 1, that is going to fall away. Then minus 1 by minus 4, that is going to simply give us 4. Okay, and 0 by minus 2, that is 0, then minus 1, that is basically going to give us 1, 1. Then 0 by 3, that is 0, so the last entry here is going to be 0. Okay, so you can go ahead and do this product of C and A the long way that we were doing here, the traditional way that we were doing here, and try to see if you're gonna find the same matrix that we have found there. Okay, yeah, that will be all for multiplication of matrices. Otherwise, on the next video, we're gonna look at row echelon form and writing an argument matrix, and what else. We are going to do some more complex stuff where we are dealing with linear equations. So stay tuned, hit that like button and subscribe until we meet again. Okay, and before I close the video, I'd like us to consider if we understand what does it mean if they give you something like this. A, let's just use a to the power 2. Okay, so a to the power 4. So basically, when they give you something of this nature, if they say a to the power 2, what they mean is that they are saying matrix A multiply by itself. So it's a times a, and a to the power 4 is a times a 4 times. Okay, so you have to to do a product of that matrix 1, 2, 3, 4 times. So you're gonna have to do the product with this one, and the product of that one, then do the product of these two. You see, so that is what it means. If you have the power of a matrix, that is how you compute it. Think about it more of when you're having variables, but in this case, you are going to be having matrices. So that is what the power in a matrix means. It means a matrix times itself. So if you are having a square, that is a matrix times itself. Okay. So yeah, let's do it again on the next video. Thank you so much for the love and support.